So let's take a look at chapter 6.1 and talk about sedimentary rocks. So by the end of this section, you should be able to explain the difference between weathering and erosion, describe how sediment gets deposited, explain the process of lithification and those two C's, know those different types of bedding, be able to explain what makes a rock angular versus rounded, as well as explain why sedimentary rocks are good at preserving fossils. So if we look at weathering and erosion first, so weathering and erosion is ultimately what causes rock to break down into smaller pieces called sediment and then get moved. So you have different types of weathering. So weathering means to break down. So you have chemical weathering where these rocks are breaking down at a chemical level. So the substance of the rock is literally changing its chemical composition because of some interaction with the environment or other type of chemical. Physical weathering, on the other hand, is where just the kind of shape or looks of the rock changes. So it happens at a physical level, like it breaks in half or it breaks down into smaller pieces. Erosion, on the other hand, is the removal or transport of that material. So that could be because of wind, water, gravity, glaciers, etc. So weathering breaks down the rock either chemically, as you can see with the statue, the face and kind of details of the statue literally get dissolved away, or with physical weathering, or also known as mechanical weathering. It's just where it breaks down in size and shape. So once these rocks and the sediment is broken down and it's transported, it eventually has to get deposited or dropped off somewhere. So if you think about depositing money in a bank, you go to the bank and you deposit money, you leave the money in the bank, you drop it off. So with deposition, these sediment, after getting moved, eventually settle out onto the ground or the bottom of a river, stream, etc. And usually you get the largest grains to settle on the bottom and then smaller on top. So if we think about how fast this is moving, faster water is usually going to carry more, whereas slower water is going to kind of deposit more a lot quicker. Wind typically moves smaller grains, so if you think about sand and dust, glaciers can move pretty much anything. Glaciers are these huge chunks of ice that can carry really anywhere from tiny pebbles to boulders the size of houses and even bigger. And then you even get landslides that'll create similar deposits like this at the bottom of slopes. And we'll talk about all of these more in chapter 7 and 8 when we start talking about weathering, erosion, and glaciers. So we have this process of lithification. So lithification is both a physical and a chemical process that ultimately leads to the formation of a sedimentary rock. So the word lithify comes from lithos, which means stone. So lithification just means turn to stone. So there's two parts to lithification. You have compaction. So over millions of years, these sediments will pile up on top of each other, and just the sheer weight of this sediment will squeeze it together. So all this pressure is going to force it into kind of narrow bands. And then you have cementation, where you're going to get water with dissolved minerals in it to work its way into the cracks between all these grains. And then as it crystallizes, that acts as the glue to help hold these grains together. So compaction is the squeezing together of sediment, and then cementation is the gluing of that. And that's ultimately, these two parts together make up the process of lithification, which is what creates a sedimentary rock. If we think about bedding, so bedding looks at the way sediment settles out of wind or water. So you get these beds of sediment that could range anywhere from a couple millimeters to several meters. And there are two different types of bedding, two different main types that we're going to talk about. You have graded bedding, and that's where you go from the smaller particles on top to the larger sediment on the bottom. And then you also have cross bedding, and this is where you're going to get this sediment to form in inclined layers across a horizontal surface. So what I mean by that, if you take a look, you'll notice with cross bedding, these are all angled. And then with graded bedding, you get those larger sediment on the bottom, and then it works its way to the finer grains on top. If we think about angular versus rounded, usually when these minerals break apart, if you think about fracturing, a lot of these minerals are going to fracture. they're going to be typically jagged shapes, very angular edges, like you see here on the left. But then the more they travel, the more they bump into each other, it's going to start to wear them down over time, and it's going to make them go from angular to a little less angular to even less angular to the point where they get rounded. And this is why we have round stones. And you get this a lot in rivers, where you have a lot of moving water. These rocks and the sediment will round a lot more. But another big factor there is the hardness of the mineral. Obviously, harder minerals are going to resist that breaking down more and will retain its shape. The softer minerals and rocks are going to weather a lot more quickly. Jumping into our last slide, we have fossils. And these sedimentary rocks are really great for finding fossils. So preserved fossils are often found in these sedimentary rocks. And the reason being, when an organism dies, if they're buried quick enough, then that organism will be trapped within the sediment. And then over time, once you have that compaction and cementation, that will lead to the fossil being preserved. So you could get parts of an organism being preserved, or you can even get an organism itself being replaced by minerals and then preserved, or you might even get trace fossils to occur, and we'll talk about that later in the year, where you're getting these kind of fossils that show evidence that this life has existed once. But again, we'll go into greater detail about these fossils later on. So I guess one other thing that I want to mention here is that the hardness of the organism kind of determines how easily it's going to be preserved. If it's a harder organism, it's more likely to leave an imprint and then get preserved, whereas something like a worm, it's going to be a lot harder for a worm to leave an imprint in a rock over long periods of time. So those soft-bodied organisms usually break down before they have a chance to leave behind evidence that they ever existed. So taking a look at this section now, we went through it pretty quickly and we covered a lot of material, but you should be able to explain the difference between weathering and erosion. You should be able to describe how sediment gets deposited, explain the process of lithofication and the 2 C's. You should know the different types of bedding, those 2 main types, be able to explain why rocks are angular versus rounded, and then also explain why sedimentary rocks are good at preserving fossils. Until next time, have a good one.